In this video, we will discuss the problem kth missing positive number in a sorted array. Problem says that we'll be given a sorted array of positive integers where all the elements are distinct, and we need to find the kth missing positive number in this array here. So let's take the first test case here. Suppose that we have the array that is 2, 3, 4, 7, 11. And the k value is 5 here. Now what are the missing elements that we have? If you see, 1 is the missing element that we have, then after that the next missing element is 5, then 6, then we have 8, 9, 10, 12, like this. Now which is the fifth missing element? 1 is the first missing element, 5 is the second missing element, 6 is the third missing element, 8 is the fourth missing element, and 9 is the fifth missing element. So that is why for the first test case the answer will be 9 here, because 9 is the first missing element that is present here. So you can see that for this test case the answer is 9. Now if you see the second test case here, so we have got k value as 2 and the array is 1, 2, 3. So which elements are missing? 4, 5, 6, 7. These elements are missing. So which is the second missing element here? The second missing element is basically 5 here. So this is how we have to generate the expected output. Now if you will see here, what is the brute force approach that we can apply? Obviously we can use mapping approach here, and we can put the data given elements of the array into a map or a set, and then we can try to check which element is the kth missing element here. Now how can we do this? Suppose that we will put all the given elements in a set here or a map. Now after this what we will do is we will update the counter. Initially my counter will be equal to 0, and I'll iterate till the counter is equal to 5. Now basically initially what will happen is, initially my current element will be 1. So whenever my current element is missing, whenever it is not there in the map or in the set, then I'll increase my counter. So is 1 there in the map? Is 1 there in the map? No, it's not. 1 is not there in the set. So that is why I'll increase the counter. Counter will become 1. So 1 is the first missing element here. You can understand 1 is the first missing element. And after that we increase the counter to 2. Is 2 missing? No. So we increase the counter to 3. Is 3 missing? No. We increase the counter to 4. Is 4 missing? No. 4 is also present. Now we increase the counter to 5. Now is 5 missing? Yes, 5 is not there in this particular array. So it will be absent in the set also. So we'll increase the counter. 5 is the second missing element. So the counter will be updated to 2 here. After that, the next element current will be at is 6. Now is 6 present? No, 6 is not present. So this means 6 is the third missing element. Update the counter to 3 here. Okay. Now after this, the current will be at 7. Is 7 missing? No. Update the counter update the current will be at 8. Now is 8 present? No, 8 is not present. So this means 8 is missing. Update the counter to 4. Okay, then after this what happens? Now the current gets updated to 9 here. Now is 9 present in the set, in the given elements? No, 9 is not present. That is why it will be absent in the set also. So that is why what you will do is you will update the counter again, and counter will be 5 here. The moment the counter reaches k, then you can stop, because you can say that the current element that is there, it is the kth missing element at the end. You can say that whenever the counter is equal to k, so the current is the kth missing element. So you can see current is equal to 9 is the kth missing element for us. So this is the way that we have applied here. Now if you will see, the time complexity will be what? Since we are linearly iterating, so this will take order of n time here, but there will be space complexity as well, because we are using a set or a map to store the existing element and check for the current every time. So this will take order of n space as well. Okay, let's discuss the code for this brute force. You can see here what we will do is, whatever elements have been given, we will insert it into a set or a map in the respective languages. Initially the counter will be 0. Okay, counter will indicate that we are currently at which missing element, first missing, second missing, and we have to find the kth missing element here. And current will start from 0 initially. Okay, then after this we update the current value. Initially the current value will become 1, then it will be 2, 3, 4, like that. If the current element is not present in the set, this means that the current is a missing element and we need to update the counter. The moment the counter becomes equal to k, then we can stop and we can say that the current element is our kth missing element here. Okay, you can see that same thing will apply for this dry run here. Now this will take order of n time complexity because we are iterating linearly, and this will take order of n space as well. Can we do it in a better way? So let us discuss the better approach for this problem. Now we can apply a linear search and solve this problem. If you will see here, the thing is that the kth missing element will be at least equal to k. One thing that is sure here is that the kth missing element is going to be at least equal to k. Why? Because if you see the test case 10, 11, 12 here, and the k value is 5, so we want to find the fifth missing element here. Now write down the missing elements: 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the missing elements that are there, and so on. Now which is the fifth missing element here? Fifth missing element is basically 5. So you can see that the answer was, or the kth missing element value is at least equal to k here, because it is equal to 5 here. Now if you see the next test case that is written here on the right side, when we have the array 1, 2, 3 and the k value is 2. So if you check what are the missing elements are basically 4 and 5, 6, 7 like this. Now, which is the second missing element here? The second missing element is basically nothing but 5 here. Correct. So the kth missing element is greater than the k value here. So you can understand one thing very clearly, that the kth missing element will either be equal to k or it will be more than the k value. Okay, if you see the third test case also, so we have got k value as 2 here. We have got the array as 2, 3, 7. Now the missing elements are what? 1, then we have got 4, 5, 6 like this. Now which is the second missing element for us? Second missing element is basically equal to nothing but 4 here. So that is why the answer will be 4. So you can see that the answer will be at least equal to k, but it can be more than k as well. Okay, now how are we checking this? If you see, let's say we have got this particular array here, that is 10, 11, 12 here. Now if we have got this array that is 10, 11, 12, what we can basically do is we can basically assume that my answer, let's say, is equal to 5. We'll try to check, but is 5 my kth missing element or not? So when we check for 5, so we are assuming that 5 will be my kth missing element here. So we are assuming that before this, definitely 1, 2, 3, 4 will also be missing. So 1, 2, 3, 4, if assuming that 1, 2, 3, 4 are missing, so 5 would be my answer. Now when I come across this particular element here, this element is 10. So 10 is what? When I come across the very first element, the element is 10. 10 is greater than 5. If 10 is greater than 5, so this indicates that there is a very big gap, and the element right now that I'm at, it is equal to 10. And I was thinking that 5 is my kth missing element. And definitely if I'm at the element 10, so this means that before this, all these elements are missing. So 5 will be my answer. So if the element at this index is greater than the value that I was looking for, in such a case, I'll say that 5 is my answer here. Now, if you see the next test case, let's say we have the test case that is 2, then we have 3, then we have 7. Okay, and the k value is equal to what? The k value is equal to 2 here. So we are finding the second missing element here. So what will happen here at this point is, initially we will say that maybe 2 is my answer. So when I'll start off, I'll think that maybe 2 is my answer here. So we'll try to check for 2. Now initially when we are checking for 2, we are assuming that 1 is already missing. Now when I check for 2, so the current element that is there, it is 2. So is 2 greater than 2? No. So this means that there is no gap and 2 is present. Since 2 is present, so 2 cannot be my kth missing element. I need to look for the next value. So my value will increase. I'll check for 3. Now when I go to the next element here, the element here is 3. So this means that if the element here that I have is equal to 3, so it indicates that the element 3 is present, and 3 cannot be my kth missing element. 3 cannot be my second missing element here. Now when I go to the next element here, now I'll increase the value and I'll check for 4. Is 4 my second missing element? So when I check here, so I will check what for 4. Now the element 7 is what? The element 7 is greater than 4 here. So since 7 is greater than 4, so expected element was 4, but the element here is 7. So since 7 is greater than 4, so this means that 4 was missing, and 4 is my kth missing element. 4 is my second missing element here. So 4 will be my answer. So whenever it happens, like, you can understand one thing, that as we keep on moving, we are increasing the value of the element that we are looking for as our answer. So if this is the array and we have the I indexing as 0, 1, 2 here, and let's say this is k plus I here, because if you see, initially the element that we are looking for is 2, then we are looking for 3, then we are looking for 4. So every time, initially we are looking for k, then we are looking for what? Initially we are looking for the element k, whether it is my answer or not. If not, then k plus 1, then we are looking for k plus 2. Like this, we keep on moving forward. So that is why we are checking for k plus I. Now if it happens that for a particular index, if the array of I is greater than the k plus I value, if the element at the ith index, if it is greater than k plus I value, this means that k plus I is my missing element. So initially you can see that my k plus I value was 2. So was 2 greater than 2? No. So 2 was not my kth missing element. Then we check for 3. Is 3 my second missing element? Now 3 is not greater than 3. So 3 is existing. So that is why 3 cannot be my second missing element. Now when I go to 7, so 7, when I go to 7, I'll check for 4. Is 4 my second missing element? When I go to 7, 7 is greater than 4. So this means that 4 is not occurring, and 4 will be my second missing element here. So this is the logic or the intuition that we are trying to apply here. Now let's do a dry run for this on the other test cases also. So let's say if I have got this test case that is 1, then we have got 2, then we have got 3 here, and the k value is given as, let us say, 2 here. Now what will happen in this particular test case here? If you see this particular test case here, so initially I'll assume that maybe 2 is my answer. Okay, maybe 2 is my missing element here. If you see, 2 is my second missing element. So initially when I'll start off, I'll assume that is like I'll try to check is 2 my second missing element here or not. So if you see the element that I have here is 1. Now if the ARR of I element at the ith index, if it is less than equal to k plus I, then this means that k plus I is not the missing element, because if I am currently checking for this k plus I element, that is nothing but 2 here. When I'm checking for this particular element 2 here, it is basically when I'm checking for 2 here, so 1 is basically less than equal to 2. So if the element is less than equal to 2, this means that the element before this is occurring. So 1 is occurring here. If 1 is occurring, then 2 cannot be my second missing element. So we'll check for the next value. We'll check for 3. So when I come to this particular element and check, so I'm checking whether 3 is my missing element or not. So when I check, so 2, the element in the array is 2. 2 is less than equal to 3. 2 is less than equal to k plus I. So this basically indicates that 2 is occurring in the array. If 2 is occurring in the array, then 3 cannot be my second missing element here. So we'll increase and we'll check for what? We'll check for like the value that is k plus I 4. Now if you check, so 3 is less than equal to 4. So this means that 3 is occurring here. So I was checking for 4, and like if the element less than 4 is occurring, so then 4 cannot be my second missing element, because if the element less than 4 is occurring, so I was assuming that 4 will be my second missing element, but an element before 4 is like occurring here, because the element in the array is less than 4. So this means that 4 cannot be my second missing element here. So we have to basically end this iteration, and when you end this iteration, you reach the end of the array. In such a case, you will return what? You will return the value that is k plus n here, because like when the k value is 2 and you have iterated throughout the array, so this means all the array from like 1 till n were present, and the k plus nth element will be the missing element here. So if the k value is 2 here, 2 plus 3 will be 5, so 5 is my missing element. So if we iterate throughout the array, in that case we have to return the value k plus 1. That k plus 1 is going to be my missing element. Otherwise, if at any index, if I find that ARR of I is greater than k plus I, then k plus I is the kth missing element for the array. So every time I keep on checking for k plus I value, if the result is less, if the ith element is less than equal to k plus I, so this means that I need to check for the next value here. K plus I is not my kth missing element. Otherwise, if the array of I is greater than k plus I, then k plus I is my kth missing element for such a case. So we need to just check this way. So let's see what we will write in terms of code here. You will iterate throughout the array, and for any index, for the very first index where we find that ARR of I is greater than k plus I, so that will be my missing element. Like once you start missing some elements, then array of I will be greater than k plus I for a lot of index later on in the array as well. But we want to find the very first occurrence where the array element is greater than k plus I. So that will be my kth missing element of the array. Now in the worst case, what will happen if we iterate throughout the array and we are not able to find the kth missing element? Then in that case, the k plus n value will be the final answer here. Now this will take order of n time complexity, because we are iterating throughout the array here, and the space complexity will be what? Space complexity will be order of 1, because we are not taking any extra spaces here. Now if you see, can we optimize this a bit more? Yes, we can apply binary search, because right now we are applying linear search. We were checking for every element of the array whether it is greater than k plus I or not, but we can do it more optimally by applying binary search and putting the low at the very first element and the high at the last element of the array. Now whatever array will be given to me, suppose, what I can do here is I can update my low initially at the starting, and I can update my high at the last element of the array. Now after that, what we will do is we'll calculate the midpoint. Now when I calculate the midpoint, and when I calculate the midpoint, so what was I checking in the brute force code? In the brute force linear code, I was checking that if the array of I was equal greater than k plus I, then this means that k plus I was my answer. If the element at the ith index was greater than k plus I, so this means that k plus I was my kth missing element. Similarly, since now mid is your index, so you will check what? You will check that if it happens that the element at the mid index, okay, if it is greater than what, will instead of I, we are going to write mid here. So if the element at the mid index, if it is greater than k plus mid here, this indicates that you have either found like if this condition happens, then you should do what? You should store this as your answer. So in your answer variable, you should store mid plus k. That mid plus k can be your kth missing element, but you want to find the very first index in the array. So that is why you need to search on the left side. So you will say that, okay, if this mid index is satisfying the criteria, well and good, but I want to find the very first index which is greater than the k plus the index value. So I want to find the very first index where the element at that index is greater than k plus the index. So that is why I'll try to search on the left side. So I'll try to search for a better answer on the left side. So it's just like applying a lower bound and finding the very first occurrence of the mid value where this condition is satisfied. So we'll update the high as what? Mid minus 1 here. Otherwise, in the else case, if the condition is not satisfied, if the condition is not satisfied, in that case, if the mid is not able to satisfy the condition, then the elements before it will also not be able to satisfy. So I need to search on the right side of mid. So I should update my low as what? As mid plus 1 here. I hope that you have understood this very clearly. So this will be the main logic for buying search. It will be just an extension of the linear search approach. So let's have a look at the code here. If you will see, what we will be doing is we'll be updating the low initially to 0, and then high will be at the last element of the array. Initially we have made the result or the answer equal to k plus n, because if you remember, if the buying if we did not find any index such that the element at that index is greater than the k plus index value, in that case the answer was k plus n. So initially by default we are updating the answer or the result as k plus n here, because if throughout the array the condition is condition of ARR of I being greater than I plus k was not satisfied, then the final answer was I plus k, sorry, k plus n. So then we'll update the answer as k plus n by default, in case if the condition is never true. Now what we will do is we'll check if the element at the mid index, if it is greater than mid plus k, then in that case we'll update the result as mid plus k. That mid plus k is going to be my kth missing element here, and we'll update the high as mid minus 1 here, because we'll try to find the very first mid where this condition is satisfied. So we'll try to search on the left side. Otherwise, if this condition is not satisfied, so we'll update the low as mid plus 1. We'll try to search on the right side of mid if the mid is not able to satisfy the condition here. And at the end, we'll return this particular result here. Now, what will be the time complexity for my code? The time complexity basically will be order of log n here, because we are iterating using binary search, and the space complexity will be basically order of 1 here. Now let's try and submit this code as well. So you can clearly see that my code is able to pass all the test cases. I hope that you have understood this clearly. Make sure to comment understood if the intuition is clear. Thank you for watching this video.